It's math time with Heinz. It's math time with Heinz. Math time.
All right, so lesson 5 here, we're going to switch gears from fractions and start working with radicals. So we're going to end up solving radical equations, but before we get to that, I kind of just want to do a mini lesson on simplifying radicals and making sure we know how to work with square roots, cube roots, and all these good things. So let's start off by listing our perfect squares and perfect cubes. So we'll do our perfect squares first. 1, 4. How am I getting these numbers? I'm just doing 1 times 1, 2 times 2, 3 times 3. 4 times 4, 5 times 5, 6 times 6, 7 times 7, 8 times 8, 9 times 9, 10 times 10, 11 times 11, 12 times 12, and we could keep going on and on and on and on. So your perfect squares you just get by multiplying your integer, your whole numbers by themselves. Perfect cubes, you're going to cube things. 1 times 1 times 1, 2 times 2 times 2, 3 times 3 times 3. And again, just do this right in your calculator. 4 times 4 times 4, 5 times 5 times 5, 6 times 6 times 6. And after that, I need my calculator. So these perfect squares and perfect cubes are numbers that you need to be able to recall or just quickly generate. They should be kind of memorized in your head, but you should be able to recognize them or get them from your calculator quickly. So let's quickly go over simplifying radicals, and then we'll start dealing with other crazier things. So when we simplify radicals, remember, I need to figure out what perfect square factor divides into 54. What is the biggest perfect square that divides into 54? Well, I think it's 9, right? Isn't it 9 times 6? So I get 3 square roots of 6. It's equivalent. It looks different, but it's really the same number. All right, what perfect square divides into 80? I'm working my way down the list here. No. 16. I think it's 16 times 5. So I get 4 radical 5 because the square root of 16 is 4. 75? Well, when I think of 75, I think of 25 and 3, right? 3/4. Well, that gives me 5 radical 3, but there's still that negative 2 hanging out front, so I get negative 10 radical 3. Ooh, 162. 162 is a fun one. And again, just start dividing down your list. No. It's 81. 81 times 2. So I get 9 radical 2, but that 2/3 is hanging outside. What is 2/3 of 9? Well, it's 6. 2/3 of 9 is 6. This is a real number. I know there's a negative, but it's only imaginary. There's only i's when the negative is inside the square root. This time it's outside the square root, so it's all good. It's just going to hang outside. I'm thinking 103. So negative 10 radical 3. And finally, 72 always stumps people because they think of 9 and 8, but there's actually a bigger perfect square. It's 36 times 2. So 9 and 8 works, but you're not going to get simplest radical form at that point. So make sure you're starting from the bigger numbers of the list and working your way down. It's not always square roots. Here I'm working with a cube root. Well, what's a square root says what times itself gives me that number. A cube root says what do I need to multiply 3 times to get this number. So when we simplify cube roots, we're going to do the same thing, except we're going to divide out perfect cubes. So let me write these perfect cubes again for you. 1, 8, 27, 64. I think that's as big as I go. So what divides into 54? Well, 27. So I've got the cube root of 27 and the cube root of 2. So this time I'm dealing with cube roots. So what's the cube root of 27? 3 times 3 times 3. So it's 3 cube roots of 2 is the same as the cube root of 54. Again, we don't do this a lot. I just want to make sure you're exposed to it. You only have i's when you have the square root of a negative. You can take the cube root of a negative number because it's actually negative 8 and 2. What times what times what gives me negative 8? Well, negative 2 times negative 2 times negative 2 is negative 8. I should have little cubes on them. I always forget them. So there's no only i's with square roots. There's no i's This is a real number. It's not imaginary. There's no imaginary numbers when we work with cube roots. When we deal with cube roots, there's no i's. Ooh, here I'm dealing with a fourth root. So I need my list of perfect fourths, whatever those are. 1 times 1 times 1 times 1. Now I need to do 2 to the fourth. And to get that, that's 16. 3 to the fourth is 81. 4 to the fourth is 256. So how do I tear apart 144? Well, I just got to see which of these numbers divides in. 81 doesn't. I bet you 16 does. It's 16 and 9. So it's the fourth root of 16 and the fourth root of 9. Well, what's the fourth root of 16? Well, that was 2 times 2 times 2 times 2. So 2 fourth roots of 9. Okay? So again, it's a little bit crazy, but it's just something I want you to be exposed to because you might encounter it later on. Where I'm not going to focus a lot on this, but you might encounter it later on. Let's deal with variables here. So express this in simplest radical form. So I've got the cube root of x to the 6th, and I've got the cube root of y to the 10th. So when we deal with cube roots, we're making groups of 3. I want to make groups of 3 when I'm dealing with a cube root. When I have a square root, I'm making groups of 2 because it's squared. A fourth root, I make groups of 4. So the question is how many groups of 3 can I make from x to the 6th? Well, I can make 2 of them, so that just becomes x squared. Here, how many groups of 3 can I make? Well, I can make 3 groups of 3, but I still have 1y left over because I had that remainder of 1. So this is really equivalent to x squared y cubed, kind of divided by 3, but there was still that 1y left over inside the cube root. All right, let's try these guys here. So let's deal with the number first, the fourth root of 32. So what were my perfect fourths? 1, 16, well, it's got to be 16. So I've got the fourth root of 16 and the fourth root of 2. So 2 fourth roots of 2. How many groups of 4 can I make there? Well, I can make 1 group of 4. And that leaves me with 2 left over. I can make 3 groups of 4. And I have 1b left over. And I can make 1 group of 4 with my c's, and I have 3 left over. So my final answer here is 2ab cubed c, and what's left in my fourth root is 2a squared b and c cubed. That's my final answer there. So we're making groups of 4 because I'm working with fourth roots. Here I'm working with a square root. Square roots are groups of 2. So first let's deal with a radical 20. Square roots, just perfect squares. Nothing. This is old school. Don't panic. Don't forget how to do easy square roots because I threw crazier stuff at you. How many groups of 2 can I make? I can make 1 of them, and there's 1 left over. And there I can make 4 groups of 2, and there's nothing left over. So I get 2a b to the fourth. Who's left over? 5a. All right, finally. Find the product of these two. Well, they're both cube roots, so let's just smush them together. 4 times 2 is 8. A to the 7th. B to the 12th. C squared. So product, we just kind of smush the square roots, the cube roots, or whatever root together and multiply them. Well, now I've got the cube root of 8. Well, 8's a perfect cube, so that's just 2. How many groups of 3 can I make? I can make 2 groups of 3. And I've got 1 left over. How many groups of 3 can I make? I can make 4 groups of 3. And then I can't make any groups of 3, so there's nothing I can do there. So my final answer is 2a squared b to the fourth cube root of ac squared. So again, when we're working with these radicals here, you're deciding that index, that's what that little number, that little 3 or that little 4 there is called the index. That's telling you what you're making groups of when it comes to variables. When it comes to numbers, you've got to know your perfect squares, your perfect cubes, or your perfect to the fourths. All right, folks, that's all we're going to do for this video because it's not a huge idea. I just wanted us to be exposed to this because it's going to pop up a little bit later in the year.